Hello and welcome to Easy Maths. This is the very last lesson on the topic of quadratic equations and expressions. We're going to look at a certain concept about graphical solution of quadratic equations, and so we just need to head there. Please like, subscribe and share. I'll always appreciate. We're going to tackle that concept by attempting a question. And so the question says, draw the graph of y is equals to 2x squared plus 5x minus 12 for the interval of negative 8 to positive 4, and use the graph to solve the following equations. We have this equation, we have another one, and another one. The part A, 2x squared plus 5x minus 12, is the same as this part of the equation we are supposed to be drawing. And therefore we just need to draw the table. I've drawn it there for you. We have done that in the previous example, and so maybe I'm not going to take you through how to come up with the actual table, only that you're supposed to generate the values of y using the x values given. For example, when you're given 8, you just put 8 squared times 2 plus negative 8 times 5 minus 12, and that answer should give you 76. This value for, say, when x is negative 3, I'm going to have negative 3 squared, which is negative 3 squared is 18 plus negative 3 times 5, which is 15, then minus 12. That should give you minus 9, and on and on. So you should do that for all the other values of x to get their corresponding y values. So having done that, we should be able to draw this sort of a curve, and that is the y is equals to 2x squared plus 5x minus 12. We're told to use that curve or graph there to solve part A, which is 2x squared plus 5x minus 12, and I say that this part is the same as this part of the equation that we're drawing, and therefore the solution for part A should be just where the graph cuts the x-axis, and you have 2 points, this point here and there's another one there. So it's just x equals to negative 4 and x equals to 1.5, and that is the answer. Those are the two answers for part A. This lesson is dedicated to part B and C a lot more because of the concepts that go in there. So this is what we should do with part B. We're told to solve this graph solve this equation using the graph of this equation. So our business here is supposed to be, first of all, we eliminate the term that has x squared in part B. This one here, we're going to eliminate it. The way we eliminate it is, first of all, by ensuring that these and these ones have the same coefficients. The first term that has the x squared here, and also this other term that's got x squared, they should have the same coefficients, so that we can subtract and so eliminate them and obtain a straight line. This is what we do. I've written y is equals to 2x squared plus 5x minus 12. That is the equation we were given at the beginning. But this other one here, I'm going to write it but multiply all through by 2. So that the coefficient of the first term is the same as the coefficient of the first term of the equation y is equals to 2x squared plus 5x minus 12. Why it's that way is because I want to subtract to eliminate the x raised to power 2, and so we have it there. Everything here multiplied by 2 gives us 2x squared plus 2x minus 12. 0 times 2 is 0. Again, this negative is signifying we are subtracting this equation, the earlier equation, subtracting the one we given in part B. And so that will give us y is equals to 3x. We have obtained a straight line, and that's ideally what we should do for all questions that are of this nature. When you're using a quadratic curve to solve another one, we should always eliminate the one we are solving, and by elimination we'll always get a straight line, and that's what we have obtained there. The solution for part B, therefore, is the x coordinates where the curve we were drawing at the beginning intersects the line we have gotten, y is equals to 3x. And therefore we first of all need to draw the line y is equals to 3x, put x to be 0, y will be 0 also, put x to be 2, y will be 6, and so we draw this line, and it's on your screen there, y is equals to 3x. Now I say that the solution for part B is the x coordinates where the graph we were drawing at the beginning intersects the line we have obtained after eliminating the x raised to power 2 of part B. And therefore we move on as follows. 1. We identify the point where the line and the curve intersect. This is the point here. And ask ourselves, what's the x coordinate? The x coordinate is 2, and again there's another point here where the graph and the line intersect, the curve and the line intersect, and the x coordinate is -3, and therefore those are the two solutions for part B. These same answers would be obtained if you used any other method to solve the quadratic equation x squared plus x minus 6 equals to 0. Let's move on to part C. The equation is 3 minus 7x minus 3x squared is equal to 0. It is not arranged in standard order, and therefore we should rearrange it and begin with 3x squared, minus 3x squared minus 7x plus 3 is equal to 0. Again, we're going to eliminate the x raised to power 2, that is the x squared term, this one. The only way we can do that is to have this coefficient here being the same as the coefficient here, so that we can eliminate by subtracting. The only way we can do it for this particular question is when we have this as 6x and this as 6x, because that is the LCM of 2 and 3. To get 6x here, we're going to multiply every term here by 3. And to get 6x here, we're going to multiply every term here by 2. And so let's go. The first one, this one, everything has been multiplied by 3, so we got to get 3y is equals to 6x squared plus 15x minus 36. That's what we have here. This other one, having rearranged and having multiplied every term by 2, we get this sort of a thing. Minus 6x squared minus 14x plus 6. And we are going to add this equation we have obtained and this other one to eliminate the x raised to power 2. And so subtracting, just adding them will be, for the x raised to power 2 terms is the same as subtracting, and therefore we're going to obtain 3y is equals to x minus 30. And so that is a straight line equation we were supposed to obtain, having eliminated the x raised to power 2 term in part C. And therefore now the value of the x that you're looking for, that is the solution for this equation, these are the x coordinates where the curve we're drawing at the beginning intersects or cuts the line we have come up with. It is so we are saying that this line was in this curve, and if you subtract this line from this curve, we should get the equation we were given at the beginning. Right? Since we have taken say this is the equation we were given at the beginning minus this curve where we have been asked to solve, we get this other one. It means these two added should give us the curve, and that's what we were doing at a previous lesson. Anyway, just get it that way. Eliminate the x raised to power 2 term, obtain a straight line, but that straight line intersects the line the curve we drew at the beginning. Those must be the solutions for the curve we are solving. And therefore we now draw a line for this 3y is equals to x minus 30, which is this one. And notice that this line intersects the curve at 2 points, this point and this other point, and the x values are, the x value of this point here is negative 2.7, and the x value of this point of intersection of the line and the curve is 0.4. And that brings me to the end of the lesson today, which is also the end of the lesson on all concepts about quadratic equations and expressions. Thank you for your comments. I encourage you to check out for the incoming lessons, errors and approximations.